Page 5. Mendel's Ark, Amy Lynn Fletcher, 2014. Biotechnology and the Future of Extinction. 1.3 Wicked Problems and Socio-Technical Imaginaries. The search for biotechnological solutions is compelling in large part because the biodiversity crisis and the associated problem of extinction is the consummate wicked problem. In policy sciences, wicked problems are characterized by uncertainty and unpredictability, a plurality of perspectives and interests, complex problems of scale, cascading consequences and scientific uncertainty. Horst W. J. Rittel and Melvin M. Webber coined the term in the early 1970s, arguing that modern society increasingly faced problems for which science designed to deal with tame problems that had clear boundaries offered no decisive or de-politicized answers. In addition, with wicked planning problems, every implemented solution is consequential. It leaves traces that cannot be undone, and every attempt to reverse a decision or to correct for the unintended consequences poses another set of wicked problems, which in turn are subject to the same dilemmas. Rittel and Webber 1973, p. 163. Writing in the United States in the early 1970s, against a backdrop of urban riots and political volatility, Rittel and Webber focused primarily on social problems. However, the wicked problem concept quickly became important in contemporary environmental studies, since it captured the complexities and value disputes that made straightforward solutions to such issues as climate change or the extinction crisis exceedingly difficult to find and implement. In the case of the extinction crisis, even gathering data becomes a complex challenge, since estimates of the potential magnitude of modern extinction rates are fraught with error, assumption and politically inspired rhetoric. MacLeod 2005, p. 80. Increasingly, we try to take control of nature through the use of advanced technologies such as somatic cell nuclear transfer, cloning, DNA barcoding and in vitro fertilization. Yet though such tools now contribute extensively to wildlife management, social scientific analysis of the evolving relationship between technology, society and the natural world is underdeveloped. Key questions that emerge in this new socio-technical space include: which species should be priorities for research and restoration using expensive technological methods, and who should make these decisions? How does the use of such tools mediate our relationship to nature and wildlife? What are the environmental and cultural ramifications of reconceptualizing life as a form of digital code? Perhaps most controversially, what are the realistic scientific and ethical limits of tools such as ancient DNA analysis and cloning with respect to resurrecting an extinct species? Despite the salience of such questions, social scientific analysis of the genomic revolution has tended to focus on such areas as human health and criminal justice rather than the environment. This book redresses this imbalance by analyzing four cross-cutting issues in the new world of technoscientific conservation. 1. Bioinformatics and the digitization of conservation. 2. Reproductive cloning of endangered species. 3. Ancient DNA analysis and prospective cloning of recently extinct species, and 4. The sequencing and analysis of DNA from long-extinct species. It introduces these tools to an interdisciplinary audience and places them within the context of the development of the biotechnology industry and the biodiversity crisis, focusing on mammals. The chapters in this book progress from the fundamental to the fantastical. Chapter 2 begins with an intellectual and cultural history of extinction in the Western tradition. Chapter 3 introduces the broad field of bioinformatics, illustrating the enduring influence of the life as code metaphor through analyses of the Encyclopedia of Life project and DNA barcoding. Chapter 4 analyzes the biomechanization of animal reproduction in the 20th century, connecting the public furors over the Onco mouse and Dolly the sheep with the new debate about the ethics of cloning highly endangered species. Chapter 5 considers the new field of ancient DNA analysis and the way in which it inevitably forces us to consider whether we could or should bring back recently extinct species, focusing on the thylacine cloning project in Australia and on the Spanish government's attempts to bring back the bucardo. Chapter 6 travels beyond the recent past to the dreamscape of deep time, prioritizing analysis of the idea that we might resurrect the woolly mammoth and other creatures from the Paleolithic period. I neither contend nor try to prove that cloning a long-extinct species like the woolly mammoth is feasibly that is a job for the molecular biologists and their colleagues. Rather, I focus on why this idea exerts such a strange fascination at this moment in time, on how it embodies our fears and fantasies about a future in which we will be able to conquer extinction and thus conquer death. The book concludes by reflecting on the de-extinction agenda and on disruptive technological advances such as synthetic biology that may make it feasible. This book draws upon 4 years of research including interviews with conservation and museum experts, archival analysis in libraries and museums in the United States and Australia, supported by funding from the University of Canterbury, and extensive document analysis of both scientific literature and mass media accounts of biotechnological conservation. Individually, the chapters reveal different policy issues and lessons, while collectively they demonstrate that our increasing reliance on biotechnology and conservation is reshaping the boundaries between the animal and the machine, the real and the artificial, and nature and culture. While each chapter illuminates specific aspects of technoscientific conservation in the age of biotechnology, the chapters also converge around key issues such as the disruptive effects of bringing new technological tools into established professional communities, the fine line between science popularization and science trivialization, and the feedback loops between science, mass media and public policy. The key theme that emerges is whether or not our increasing reliance on biotechnology and conservation enhances or undermines our relationship to what we define as wilderness. For proponents, the de-extinction narrative encompasses a progressive view of biotechnology as the solution to the biodiversity crisis, while, for opponents, it raises a false and dangerous hope that distracts from pressing problems of habitat destruction and climate change. Similarly, DNA barcoding and reproductive cloning are presented by advocates as essential to a lush and viable future, while critics tend to see only tools that will finally replace the real and tangible animal with a string of bio-digital code. Page 7.